Hi everyone, this is the first lesson on mechanics. We're just going to go over some really basic stuff, so some quantities and some units. It should be quite a nice short video, but some quite important stuff here just to get to grips with the overall nature of mechanics, what it's all about, a few quantities, a few units, a bit about gravity and mass and weight as well at the end of this lesson. This is what we're going to go over, just a little bit about what mechanics actually is, what we're going to be studying, a little bit about units, scalars and vectors, which you may have talked about in physics before, but we'll go over them as well. Some very simple unit conversions. You're unlikely to need those in the exam, but you do need to have an idea of how we do conversions if necessary. And a bit about gravity at the end, which might be something new, but you might have covered it in physics possibly, and a quick practice question at the end. So what is mechanics about? Well, very simply, it's a study of motion and the forces that cause motion. So we're looking at mostly distances, velocities, accelerations, and forces, and how those things link together. So how much force do we need to cause a certain acceleration? How, if we have a certain acceleration, what velocity do we get to in what time, and what distance do we cover in that time? So it's basically how these things link together. It's if you quite like physics and engineering, this will probably be quite interesting to you. It's kind of like a how the world works sort of thing. Lots of applications here to cars and planes and anything which moves basically, and the forces they need to achieve the accelerations they desire and get to the velocities that they need to get to. So lots of interesting applications here. So we've just got a big list of units to have a quick look at. Lots of these you'll know already, some might be new, but it's important to have an idea of the units of various quantities. Distance, obviously measured in meters with the symbol m. I'm sure that one's not new to you. These are all the SI units. So they're what we call like the standard, like the base units, if you like. We always try to use these base units. So instead of using kilometers or millimeters, we'll try and convert everything into meters, just in the same way we do in physics. We always try and convert to those units before we use formulas, and it's the same thing in mechanics. So we'll always use meters instead of kilometers. We'll always use newtons instead of kilonewtons, that kind of thing. So I've listed all the kind of the base units here. Speed is in meters per second. Now, you probably spent a lot of time writing meters per second like this, m/s. That's fine, nothing wrong with that. You can still write that if you like, but we tend to use this notation now, where we'll write meters seconds to the -1. Now, hopefully you remember from pure maths that s-1 means 1 over s, right? So it's exactly the same thing, but we tend to start writing it like this in A level now. So you'll mostly see, instead of per second, you'll see s to the -1, and the same with other units as well. Acceleration is a bit more of an interesting one, the unit of this. Acceleration is how fast your speed is changing. Speed is measured in meters per second, so acceleration is measured in meters per second squared, or meters per second, okay? If I have an acceleration of 1 meter per second, or 1 meter per second squared, that means I might start at 10 meters per second. After 1 second, I'm doing 11 meters per second. Another second, I'm doing 12 meters per second. Another second, I'm doing 13 meters per second. Okay, so I'm increasing my velocity at 1 meter per second every second. If I had an acceleration of 3 meters per second, I might start at 5 meters per second. After 1 second, I'm doing 8 meters per second. Another second, I'm doing 11 meters per second, and so on and so on. So hopefully you can see how that works as an acceleration and why the unit is meter per second squared. It's because it's the meters per second that you're changing, the velocity, for every second. Force, measured in newtons, okay? There's lots of different names for forces. So we can have tension is a type of force. Weight is also a type of force, as we'll see later on. Pushes, pulls are obviously forces. So forces tend to have lots of different names, but they all fall under the category of force. and therefore have the units of newtons. So tension and weight both have units of newtons as well because they're just forces. Mass, which is different to weight, as we'll see in a second, is measured in kilograms, kg. I'm sure you'll have seen these before in physics. Time, measured in seconds. Okay, so they're pretty much all the units we're going to be involved with. I don't foresee you'll be using any different ones, to be honest. Scalars and vectors. Maybe something you've talked about before, but possibly not, so we'll go over this. Scalars are quantities they only have a size, also called a magnitude sometimes. They just have, we just say how big they are. That's all we know about them. Vectors have both a size and a directions. As well as saying how big they are, we have to have a concept of what direction they point in as well. Now, just by saying a certain name, we can tell whether it is a scalar or a velocity. I'll give you a list here of well-known scalars and velocities. Now, distance is a scalar. I can say a distance of 10 meters, and it's just got a size, okay? So this has only got size, no direction. However, it does have a vector equivalent called displacement. This has size and direction. So if I have a displacement, I need to say 10 meters due north, or 10 meters on a bearing of 076 degrees, or something like that, because it has a size and a direction. Okay, so vectors have got some concept of which direction they go. It means as well that displacements can be negative. I can say minus 10 meters for a displacement, and it has an idea that it's going backwards. It has a direction associated with it. A distance of minus 10 meters doesn't really make any sense. Scalars should always be positive, whereas vectors can be positive and negative because they can have an idea of going backwards. Speed is a scalar. I can say it's traveling at 10 meters per second, and that's enough. However, a velocity, and you probably may have used these words interchangeably, but they're not quite the same in maths and physics. You can have a speed of 10 meters per second, but a velocity of 10 meters per second in an easterly direction. Again, velocities can be negative, so we can have a velocity of minus 20 meters per second, but we can't really have a speed of minus 20 meters per second. It may seem like this is a tiny difference, but it does change quite a lot how we analyze between scalars and vectors, which, to be honest, you won't see so much in this course. You see a little bit, but as you get into more complicated mechanics, vectors tend to be treated in quite a different way. And you've done a little bit about vectors already in pure maths, where you write things like 5i plus 6j. That's a vector, and that has a direction, doesn't it? As well as having a size. If we square and square root, we can get the size, whatever that is. Root 66, 71. It also has a direction. It sort of points that kind of way, doesn't it? 5i plus 6j. So it has a direction associated with it. Scalars we don't write like this. We just write as one number because it only has a size. Anything with magnitude in front of it is a scalar, so magnitude just means that it only has size. Acceleration itself is actually a vector, so acceleration you can write as a vector with i's and j's like this, and it has an idea of which direction we're accelerating in. Time is a scalar. You might think, well, time moves forwards, but that's not really what we mean. We're talking about spatial direction. Time doesn't go north or east or on a bearing. It's a scalar. It's got no concept of direction, really. Force is always a vector. It's always got some direction associated with it. Which direction is that force acting in? Does it make the object move forwards or backwards or left or right? Mass is another example of a scalar. You can have a mass of 50 kilograms. It doesn't have direction. Now you may be thinking, well, it pulls us down. That isn't what mass is. Mass is just about how much stuff there is. So it's just kind of an idea of how much stuff there is inside something. So mass doesn't pull you down. Mass is just how much stuff there is inside you. Okay. Now weight is a vector. Mass and weight are different. Mass is a scalar, just says how much stuff is inside you. Weight is the force which pulls you towards the ground. Okay, now that is a function of mass. It depends on what your mass is, but it's different. Weight is just a force as well, so it has units of newtons. Energy is another example of a scalar. Momentum is a vector. I may have talked about momentum in physics before. It's the mass times the velocity. We don't really need to know about it in this course, but because it's got a concept of velocity, it's got a concept of direction as well. Got a little bit here about converting units. So compound units have got two units within them. So velocity, for instance, has got meters per second. It's got a distance and a time in it. If we're converting from kilometers per hour to meters per second, we've got to change from kilometers to meters. That's one conversion. And from hours to seconds, that's another conversion. Okay. You'll probably have done this kind of stuff before, but just make sure you can do these conversions when we have compound units. So let's just do one quickly. If we've got 180 kilometers per hour and we have to change to meters per second, what do? Well, 180 kilometers is 180,000 meters. Okay, so that's one of the conversions done. So we could write this as 180,000 meters even, per hour. Okay, and now we need to convert from hours to seconds. And what's the conversion for that? Well, there's 3,600 seconds, or 60 times 60, in an hour. Okay, there's 60 minutes in an hour, and then 60 seconds in a minute, so that gives you 3,600 seconds in an hour. So that means you've got 180,000 divided by 3,600, because we're going from hours to seconds, meters per second. Okay, I'll put that in the calculator. We get 50. Okay, so it turns out 180 kilometers per hour is 50 meters per second. Okay, so you just do each of the conversions separately, convert the kilometers to meters, and then the hours into seconds.